Hello, everybody. Today is our third day of RSK Academy, and I will talk about the blockchain, Bitcoin, Ethereum, and RSK. So this is the most theoretical class that we have because we only have one practical part at the end. But first of all, we are talking about the concepts, the fundamentals of this technology. So welcome everybody. Do you know me? Do you know Academy? So this is all the topics that we are covering today. We are talking about the blockchain, the fundamentals, Bitcoin, Ethereum, and RSK. Hi, Derek and Neil. Good to see you again. Let's start with blockchain. Blockchain, like your name said, this is the chain of blocks. So here we have the first block, for example. And what do you have in blocks? In fact, all blocks have many transactions, and the transactions can be for transfer cryptocurrencies or for smart contracts too. But this is one block. This block is linked to the next block. And we can check this with the previous block is the same hash from the proof of work block 1, okay? And it will be the same. So I have the third block, and here I have 4 blocks. One very important point is that if I try to change something on a transaction in the first block, it will change the hash of the block 1, and it will change the hash of block 2 and block 3 and block 4 and all of the blocks that we have done after that block. It means that to change something in the past, you need to change every block that was mined after this. And this is very difficult. Because of this, we say that the blockchain is immutable. And also, it's not about change everything, but it's also about more part of the miners, 50% or more of the block miners, the validators, they must agree with this change. So, if you are trying to do something wrong, they will not allow you. They will not agree on change a transaction in the past. And because of this, we can say that the blockchain is immutable. When we are talking about transactions, we are also talking about a state machine. Thinking about photographs or drawings, I have one draw where the state is 1, the balance, it's in Portuguese, oh, sorry. The balance is 10 and the information is A. And I'd like to have a new photograph with the state 2, the balance 5, and the information B. To do this change, I need to have a transaction. The transactions make the changes in the word state, change the state machine. So we are talking about change photographs, change movements, okay? Here I have the word state, and the changes in the word states are in the transactions, and the transactions are validated in the blockchain. So we have the blocks between two word states. And here we have the transactions that it's making the changes. Okay? About the fundamentals. When we are talking about the blockchain, blockchain is based on cryptography, distributed systems, and the game theory. Cryptography, it's a Greek word. We are talking about the hidden and the written. So this is the study of techniques to change messages. Only the destinatary of the message will understand the message if he or she knows the whole. We have some rules to change the messages. I have one basic cryptographic is the Caesar cipher. Like I'm change a letter by adding 3 positions and change from to lowercase. And for example, in this Caesar cipher, this message will be this. And only the person who knows that this is the rule will discover the real message. In the same way, we have other kinds of cryptography techniques, and these techniques are used in blockchain. So in blockchain, we use the hash function, the public key and private key, and the Merkle tree. What's a hash function? It's an algorithm that maps data, that variable length data, to a fixed length data. And we have, for example, a document that will be changed for binary for zeros and ones. Then it's go to the hash function. And in the end, we have the document hash. And this is an example. It's important to say that the hash is deterministic, so it will be always in the same way. To be better about this, it's like the same entry will always result in the same exit. It's fast, it's one way. From the hash, it's not possible to return it to the original. And a small change in the input will generate a completely different hash. It seems like random. Also, it's collision resistant. Two documents not generate the same hash, not for the hash that we use in the blockchain. It's the SHA-256. For another simple hashes like the MD5 that used to in zip files, for example, it can have a collision, but not for the blockchain. Another important point to talk about the cryptography in general, and this is in blockchain, we are talking about information security. So it's the confidentiality, the data integrity, the authentication, and the non-repudiation of a message or a transaction. Here I have an experimental for you. You can do this later. And let's talk about cryptographic keys. We have two types, the symmetric keys and the asymmetric keys. We use the keys asymmetric because this is the public key and private key. And we have two uses of this. For the cryptography side, any person can encrypt a message using the destinatory public key, but only the owner of the private key is able to decrypt the encrypted message with this public key because he knows the private key. So this is one use. The other use is the authentication. Only the owner of the private key can sign or authorize a transaction from the corresponding public key. And the public key can verify that the holder of the private key sent the message. This is the basic for send cryptocurrency, because what the validator do, what the miner do. The miner check this with the signature of a transaction is from the person who have the public key. So the public key is sending a transaction that is signed by the private key. Here I have a illustration here in Portuguese too. Sorry, but this is the original data. We have the cryptography algorithm, and with the private key, we can convert for one side and for the other side. Another point for cryptography, it's the Merkle tree. It's not the Merkel tree, this is a joke, but it's the Merkle tree. And the Merkle tree, it's a binary registry. So we have a data structure for store information in large data sets, like many transactions in the same block. And the verification of this data set, is done in an efficient way. And if we try to change some transaction, like I said before, you need to change all the Merkle tree. So this is an anti-fraud mechanism too. Like here I have a good example. Like I'd like to check the hash of the cut doc. This is an image. And also I have a document and a text file and another kind of image. So to verify this or to change this, wherever, I need to create the hash of this. I need to know the hash of this, the contract, and these two will be together, the hash of C plus D. But for the side, the left side, I don't need to know the basic. I only need to know the hash of AB. And then I can check the final hash here. I like so much the definition of Andreas Antonopoulos in the book The Bitcoin Protocol, that Merkle trees are used to summarize all the transactions in a block, producing an overall digital fingerprint of the entire set of transactions, providing a very efficient process to verify whether a transaction is included in a block. This concept of a digital fingerprint of a block, it's amazing, and this is real because the hash. Here I'm showing an example of this. So I have 4 transactions. I can have 100 transactions, for example, in a block, and they are combined by 2 because we are talking about binary trees until I have the root of the transactions. And also in this block, I have the previous hash. I have a timestamp. This is the date and time of the block. And I have the nonce. This is a number that it's discovered by try 2 in order to be my block validated. This is another illustration for the same. We talk about it. And the third point, when we are talking about the blockchain, it's about the distributed networks. So these are the diagrams of Paul Baran. He published this in 1964. It's very old, but this is one of the best ways to present the distributed networks. And here we are, we have the blockchain. On every node can communicate with all the nodes. We don't have any restrictions over there. Also, we can represent the ledger, the transactions. The ledger is the database of the transactions. We can represent the ledger of the states that we're talking about. Remember the state machine? Distributed. Every computer has a copy of this. And the third point that we are talking about is the game theory. So, what is this now? We are not talking about video games or board games. This is the study of decision making between individuals. When the outcome of each depends on the decisions of the others. It's like it's a game like interdependency. So, in other words, it's the study of probabilities in decision making. And this is a very no problem in the game theory, the problem of the Byzantine generals, because they need to attack a place, but they only will have successful if they attack in the same time. So they need to coordinate the time to attack. And they are separated by mountains. And how to coordinate this? They are sending message to others, commandant, but if one of them send a false message, they will fail. So they need to find a way to be sure that the message is true. And this is like this that we need to have in the blockchain. So when we're talking about the Byzantine generals, we are talking about the consensus. This is the mechanism to ensure that the parts agree that a certain state in the system is correct. We are trying to discover the truth. And when we are talking in blockchain, we have different ways to have the consensus. The proof of work is the most important. These were implemented in Bitcoin, the first blockchain. The concepts are very old too. And the most important point is the asymmetry, because it's very difficult to calculate the proof of work, but it's possible. But if you know the number, that's the nonce that I mentioned before, it's very easy to check. And based on the proof of work, Adam Beck proposed a way to decrease the spam in emails using the SHA-1 hash calculations. So for each email that you will send, you need to do a calculation using the email, the person email. And because of this, you are having a computer you are using your computer for each email that you are sending. And this is a way to send a message to the persons that, hey, I'm using my computer. This is hard to do. So this is not a spam. This is a real message. I'm doing an effort to send this message for you. And the proof of work in blockchain is the same kind of concept. So it's a test of a computational work where we are spending the process and the energy. The idea is ensure the decentralization and the security of the distributed transactions. So we are talking about mathematical calculations that miners do on their computer to verify that the transactions are valid. Very good question. The mining comes from the discovery of knowns, which is the process of trial and error to find the number that satisfies the degree of difficulty of the network. So I will demonstrate this now. It's a good moment to do this. Remember that I said before that I have a link here. I will copy this link. And here in Academy, this lesson is already published. So if I came to courses, develop, I can see here the blockchain lesson about all the fundamentals in English, okay? And we are talking here. We have the fundamentals here. I will put some images, but we can check this. So this is the blockchain demo. You can check it after. And I will go here to the hash. I can put wherever here. Yes, this is our lessons. And this is the Anders blockchain demo. Like here, to do the hash, I can put, for example, the word document. Document here. And I have a hash. Look this. If I put 1 in the end, I will have a completely different hash. It's not only change a number, it's change everything. If I put a space that I cannot see, here, change completely. So this is very interesting to you understand the blockchain. You can check here in the hash, okay? Here, I will change. So go to the block. Here is the block. Yes, I sent the link of this lesson, and I sent the link for the blockchain demonstration that we are doing here. Okay? And take a look here. This hash, this green, because the hash is create a valid block. This is valid because I have a hash that begins with 4 zeros. This is the nonce that I need to have to create this. Take a look on this. I don't have nothing on the data part, but I will create a transaction. Transaction 1. Now the hash of the block changed because I have a transaction. I need to discover the new number here, the nonce, in order to my block be valid again. So I will try to mine this. What's the mining process do? It will try every number one by one. Like I can do it manually. 1, no, 2, 3, 4, 5. So I try to mine. Yes, with this new number, my hash begins with 4 zeros. I'd like to add one more transaction, the transaction 2. The hash change again. So I can try it one by one manually, but in fact this software will do this for me. And this I have a new number higher than the other, do you remember? And now again my block is validated. I have a valid block. If I go to the blockchain part, I have more blocks over there. And all of them are green. They are valid now. They started with 4 zeros, like here. The second block has the hash of the previous block here. So everything is good. I put a transaction here. Now, this is not valid anymore, and neither this or this, or I know that I have 5 blocks. So I need to do every again. If I validated the first block, so I will discover the nonce of the first block. Here is the nonce, it's a bigger number. Now this block is valid, but I have this in the second block. I need to mine the second block again. Here, this is a nonce lower. And do you understand that I need to do the same for all blocks that I have after the block that I would like to change? Because of this, we can say that this is immutable, because the people will not allow to do this. Imagine that you need to do this and most part of the computers must agree. So with this, I need to mine every block again. This is a big effort. So I will come back here, because now we are talking about the proof of work, but we have other kinds of consensus models. Like the proof of stake is known by proof of participation. So here we have, for example, we need to stake your coins, to stake your cryptocurrencies. So the validator, you deposit your cryptocurrencies in a kind of safe, or you'll be locked, to prove his participation, to prove that he is the owner of these coins. And if you have more coins, it's greater the chance of validating transactions and earning from them. This spends less energy than the proof of work, and this is supposed to be more secure and more decentralized, but in fact I don't agree, because the validators that have more coins, they have more chances of get more. So it's not so decentralized. And I also forget to say that in the proof of work process, the validator who create the new block, he will win a reward for this. I will talk about this in the Bitcoin. Another third kind of consensus that it's common, it's the proof of authority. It's used in the permissioned blockchains. We have a group of authorities. We have a permission. So nodes defined and authorized to create new blocks in a chain. And also it needs approval from the most part of the nodes to a block be created or to be part in this network. And we have this in some kind of Ethereum permissioned networks, or some testnets or quorum. initially from JP Morgan, now is from Consensus. And let's talk about the Bitcoin. The Bitcoin is the first cryptocurrency, and the goal is to have a digital money, decentralized, safe, open source, and self-regulated. But the Bitcoin, it's much bigger than this. This is amazing. Here I have the PDF of the Bitcoin, and I will read only the first phrase because this is very important. We are talking about a peer-to-peer version of electronic cash that would allow online payments to be sent directly from one party to another without going through a financial institution. No intermediaries, no third parties. This was published in the white paper of Bitcoin in October of 2008 in the discussion group, the Cryptography mailing, by the pseudonym user Satoshi Nakamoto. We, until now, and I think we will never know who is Satoshi Nakamoto. It can be a person or a group of persons. And the source code of the Bitcoin, the node, started running the network on January of 2009. Bitcoin solves the problem of decentralization, the double spend, I will talk more about it, the identity, the issuance, the mint of coins, and the consensus. This allows the peer-to-peer payment from a user to another user and no intermediaries. And the most important part here is the double spend. Because you can imagine it now, we are talking about to do this in the internet. And I can send a file for you and you still have a copy of the file. I can send the image for you and have a copy of the image. But how can I send a money for you and still have a copy of the money? It's not possible. And so this is the most important problem that the Satoshi Nakamoto solves, that the double spend. Yes, when we are talking about the Bitcoin, Bitcoin is the network, but it's also the name of the coin. The network and the coin have the same name, and the coin, named Bitcoin, has the symbol BTC. So this is the BTC currency, is the symbol of the Bitcoin network. We can define Bitcoin in many ways, like a protocol that defines a decentralized peer-to-peer network. Like we said before, it's a blockchain, so we have a public ledger with transaction. Bitcoin also has a set of rules to validating the transactions, a mechanism for reaching consensus, the proof of work that we talked before, and it also has an economic system that rewards the participation, minting and creating new Bitcoins. And we have this creation, it's cut by half in 4 years. So last year we changed from 12.5 Bitcoins to 6.25 Bitcoins per block. And I really love this quote from Antonopoulos too, and I have a translation in Portuguese here. But Bitcoin is not unregulated. It's regulated by algorithm instead of being regulated by government bureaucracies. It's uncorrupted. This is very, very important. And let's talking a bit about the mining process. What's the mining process? I showed before in the blockchain website that this is a dispute to find a hash of a block less than the current difficulty level before the others. The difficulty level in our example is to have 4 zeros. So this dispute makes the persons do this to win the new bitcoins, and they are doing the security of the blockchain network and the validation of the transactions. About the reward, the block must contain a Coinbase transaction. What means? Are transactions that will go to the miner address. The amount of Bitcoin, it's halving. We call this event half, the half, and it's supposed to stop to have Bitcoins in 2140. Okay, I think we are not here until then. But in this moment, the miners will win only a fee for validating the transactions. Now they win this fee also, but the miners win some amount of bitcoins that are created too. And let's talk about Ethereum. Ethereum, it's a global platform, open source, and we are talking about it's a platform to have decentralized applications. So we are talking about a decentralized mining network that incorporates a software development platform capable of executing smart contracts and decentralized applications using the blockchain technology. We talking a bit about the smart contracts on last class. So these applications are the smart contracts. They work exactly as programmed. There is no possibility of censorship, fraud, or interference of third parties. The source code of the smart contract is immutable. I think I have a message here. Yes, I can talk a bit more about the smart contract. Smart contract, it's a program of computer. It's a computer program. Like any other, but it's published in the blockchain. Because it is published in the blockchain, and do you remember that when transactions are published in the blockchain, we cannot change the transaction after? We can say that this computer program is immutable. And when we are doing transactions after this, like to call a function that it's defined in the smart contract, we cannot change the rules because the rules are right in the smart contract, and the smart contract is immutable. This is the basic. We can talk more about this after. It's very important to know the person who creates the Ethereum. This is Vitalik Buterin. He's the co-founder of the Bitcoin magazine in 2011. And this is very interesting because Vitalik Buterin was part of the Bitcoin community. So he's a very active person in Bitcoin community. But he views the blockchain. The blockchain could go far beyond transactions for cryptocurrencies transfers. Like we can do more with the blockchain. We can not only transfer cryptos, we can do other things. We can run programs. But he don't have a consensus in the Bitcoin community to implement his ideas on the Bitcoin blockchain. So he created the Ethereum blockchain, another blockchain. It's important to know that the Ethereum is not a Bitcoin chain, that is not a fork. It's a new development. It's completely new from scratch. And we are talking about RSK now. Before talk about RSK, it's important to talk about the what's a side chain, because RSK is a side chain. So a side chain, it's parallel to another chain. So it must have some kind of connection with the main chain. But in the same time, it's an independent blockchain. It has a native currency that it's pegged to the value of another blockchain currency. And also it has a two-way peg system. So this is imposed by a protocol that allows two currencies to be exchanged in a freely way, automatically and without a price negotiation. And to talk more about it, with RSK, it's a Bitcoin sidechain with the ability to execute the Ethereum smart contracts. For me, this is the best of the both worlds, because I have the power of the Bitcoin, the security of the Bitcoin, and I have in the same way the all the things that I can do with a smart contract, Ethereum smart contract. So I really love this. And yes, in a side chain, we have the same value, the same exchange rate all time. For example, for RSK, the cryptocurrency is the RBTC, and his value is tied to Bitcoin. So one RBTC, it's equal to one Bitcoin all time. We can say that a side chain, it's a layer 2 of Bitcoin. Yes, Joey, we can say this. Our layer 2 is a side chain. In fact, is this. Here I have a picture, like I have Bitcoin to store value, and I have the RSK like the business logic of the smart contracts. And I love this quote from Nick Szabo. Nick Szabo was the creator of the smart contracts, and he created the smart contracts very early. We don't have a blockchain to execute it. And Nick Szabo said in a talk on scaling Bitcoin that layer 1, it's like the digital gold, and layer 2, it's the digital cash. And like RSK, it's an example of layer 2 for smart contracts. When we are talking about the RSK, so we are based on Bitcoin, but we execute the same smart contracts from Ethereum, but we have one more layer. This is the reef layer, the RSK infrastructure framework. It's like a set of tools that we can use to speed up our development, and makes easy to have new applications. For example, in RSK Academy, when we are using the feature connect to a wallet, this is a feature from RIF. This is the R login, a feature from RIF that we are using in RSK Academy. And let's go. Here I have a picture to understand better how it's working, because it's using the payment proofs, the SPV proofs, and we have some confirmation periods to move your Bitcoin to be a second, in our case, to be a RBC, and lock your Bitcoin to have the RBCs and come back. I will explain more in the next. So this we are talking about. RSK, it's a Bitcoin sidechain. A SPV proof, it's a kind of part of the Merkle tree. Do you remember the Merkle tree? It's a part of them that can prove that a payment is done. It's confirmed in the blockchain. Without, you need to have all the blockchain. This is the only hash that is proving this. And this is important in the two-way peg. I will talk more about it. First, we have two important points when we are talking about this sidechain. We need to know the merged mining concept and the two-way peg concept, that is the bridge. The merged mining is this. The miners of Bitcoin, they also are validating, are mining the transactions of the RSK blockchain. In the RSK blockchain, we don't create new coins because the coins are created in the Bitcoin. The miners in the RSK chain are win the fees for the execution of the transactions only. But is the miner use the same software to do both. So for them, it's very great because they can win more using the same software with the same effort. Like this, so the RSK blockchain is mined simultaneously with the Bitcoin blockchain. We have no additional cost. Both networks use the same proof of work algorithm, the double SHA-256, and the Bitcoin mining pools include a reference to the RSK block in every mining they deliver. And I have an interesting picture here, like this is the miner, this is the pool that I said before, and they can validate the transactions for the Bitcoin and for the Bitcoin below and for the RSK above. One difference is in RSK network, the blocks are created every 30 seconds. It's faster like Ethereum. Ethereum are 50 seconds. We need this to ensure the execution of smart contracts. Bitcoin has a block time in 10 minutes. We cannot wait 10 minutes to have a smart contract. It's not possible. So because of this, we have 30 seconds. It's a good time to do the broadcast in the network. And I said this before, we are not creating new currencies. It has the reward of mining in the RSK network. They are the fees. The miners earn the fees. So is this no additional cost or impact? This is a picture only. Here. This is the other important point. This is the two-way peg. The two-way peg, it's like this. We have a point of locked Bitcoins or RBCs. It's Bitcoin. I locked my Bitcoin in the main chain, in the Bitcoin, and I will unlock them in the second chain. This is the RSK, and I can use the RBC here. When I would like to come back, I will send my RBC back to the vault to be unlocked, and I will have my BTC again. Maybe not the same amount because maybe I used a part of the Bitcoin to execute smart contract. Maybe I can have more because I use my RBC in a DeFi protocol and I win some. And yes, Joe, the bridges collect revenue for the service. It's a little fee. And this is the two-way peg, the component that I'm talking before. He's connect the BTC and the RSK networks and allows the transfer for the both sides. We have basically the fee is the payment in the execution of the smart contract. It's not an extra fee, okay? How is this process? I send the Bitcoin to a special address. The BTCs will be blocked in the Bitcoin network. This is the pegging part. So the BTCs are transformed into RBTCs. They are used in the RSK network one by one. And in some moment, I can do the other process, the peg out. So the RBTCs are transformed into BTCs again. And this is an animation that is showing this. No, come back. I think this is a bit slow, but we can do the Bitcoin is going to the RSK and it will be locked here. And in some moment, the other process will be done. Okay? And like I said before, the RSK, it's very near the Ethereum. I love Ethereum. I am an Ethereum developer. I love to do smart contracts. And the RVM, the RSK virtual machine, is compatible with the Ethereum virtual machine, the EVM. So we can use many tools made for Ethereum developers. Like we try last week, we use Remix. We also are using the wallets like the Nifty wallet or the MetaMask. But we will learn in the course another tools. We will use Truffle, Open Zeppelin. We have the gas station. We will use the HD wallet provider, Web3. So it's almost the same. And I don't know, probably we don't need the pad today. So do you have questions? We are doing a practical part now. It's an easy part. What you are doing now? Last week, we need to validate our name smart contract on the RSK Academy. I will do a bit review about it, and then we are validating this. Like I am here in the third class now, you know, you can check this part, okay? So first of all, I will connect my Nifty with the RSK Academy. Here I'm using the R login from Reef that I said before. It thinks that I have MetaMask because I need to refresh my page. I was using MetaMask until 5 minutes before start here. So now I have Nifty. We can check that this is my account. It begins with 50 and 50. It's okay. It's my account, I'm sure. But I don't know if I have a smart contract in this account. I really don't know. I'll try. I'm not sure. Like I go to the Explorer. Like this is a contract call. Yes. But I think I don't have the name smart contract here. Maybe it's this. I don't know. You can check it. You check it. This is a cow. I didn't create the smart contract name here. I can check if I am a student. I don't know. I am not a student. So the first thing that you do is the subscribe in the course again. You do this before. I didn't. Not in this account. So I came here and I will subscribe to the course again. You don't need to do this, okay? This was our first class. And now to go to our second class, I will do this now. Where is the second class? Here. I need to use the smart contract. I'm waiting the subscribe. I can check it here. Okay. This process, it's a bit, it takes more time than other process because this is a big smart contract. It's using almost one block for do everything. But in the same time, I can check here. Why so small? Okay, here is better. Like I have the name contract. We did this in last class. Okay. I will put my name here, not Mickey Mouse now. This is my name. And I will publish my smart contract with this account. I have it with another account. I'd like to do it again. Where is here? We are still waiting this transaction. Let's check my transaction here too. Here I can check. It's pending. Oh, it's successful now. Oh, okay. So in 1 minute, I can, here it's confirmed. So now I am a student. Great. I can go here and I have my data here. Okay. So I will come to the smart contract. You did this last class. I will create my smart contract again. I'm here. I will go to the fourth button, change the environment to injected Web3. It's only a review for you. And deploy my smart contract name. Here we are. Wait a bit more, and I will have my smart contract here. Now it's big. We are waiting my smart contract name here, okay? And the next step we can do together. I will pick up information for you. Like this was the student in the last class. So we have your contract here. Maybe you can use this. Wait a minute for me for I have my transaction. And this next part, it's so cool because you will see your name now in the smart contract. I really love it. Wow, what's taking so long today? Oh, here. This is my smart contract name. This is my name, and I am the owner. So I will copy my name again. You have this in the last class. You don't need to do it again. we need to validate our smart contract name. This is a new lesson that it was not here last week, okay? And maybe we can do this in the pad, it'll be better. I create this pad for us now. Let's do it together. This is the pad, this is a new pad. So I'm creating this just now for us. And we can have this. This information is useful for you. We are in the blockchain lesson. And one more information for N. And here in the smart contract lesson, you can learn more about the smart contracts in the introduction to smart contracts. Okay? You have more explanations about the history and what is a smart contract. So I come back, and I'd like you to do this with me, okay? We can do this together. What I need to do here? This is the master name. Do you remember that I said on the last class? And I validated my name, but not me. This smart contract master name, you validate my name, okay? And yes, Annie, you can also do the lessons 1 to 3. This is the 3, but you can check the other lessons. You can start it here in the wallet, do everything. And in the same time, if you came into the live classes, and if you click in each lesson, you can also watch the video for the last lesson, okay? All the past lessons are in the videos too. It's very easy. And also, if you have some doubts, you can join us in our open Slack in the channel English Academy. And me and other persons are helping all the students here. Perfect. And we are here in the validating our name project. What I need to do? I need to put my name, and I need to add the address of my smart contract name. Here we are. Important rules. If you put a different name, like I do error now. I try to be the Mickey Mouse. And this account must be the owner of this smart contract, okay? And this smart contract must have the name Mickey Mouse. We know that doesn't have. This is an error, only to show you what will happen. I will confirm my transaction, but this transaction will fail because the name that I stored on this smart contract is not Mickey Mouse. Is my name, it's Solange Gueiros. We can wait a bit and check this. You don't need to do the error, so do the right way. Put your smart contract here, connect to your wallet first, put your smart contract here, paste it, paste your name, and click to set your name on the Academy. We are waiting. You can add your name here too. Like this is me. You can add your name. And my transaction is confirmed here, but it's failed. Why it's failed? because I'm not Mickey Mouse. I am Solange Gueiros. This name was saved in my smart contract. So I will try again, and now I'm sure that I will do right. Again, I am in Nifty. Click on Submit. And I need to wait again. Wait a minute. And what are you doing too? Here you can put great Neil, thank you for put your name, and you can set if it's registered. We can put the transaction here. It take a long time, but it will be done in 1 minute. Here we are. Done. Transaction confirmed. And oh, this is true. It's validated because it's I write my name, my right name now. So this smart contract validated that the name I have here is the same name that I put here, I paste here. This smart contract address is the same that I paste here, and this the owner of this smart contract is the same account that it's connected. We need to have these 3 points to be right, okay? And if you go to your profile now, I need to refresh my profile and log in again. And it's supposed to show my name here. I will check it after why my name is not here, but your name will be here in the future. It's very, very important. In your name in the next, for the next week, your name will be here, okay? Great, Neil, I will put my transaction too. This is mine. Here. Joey, your transaction failed. We need to check if your account is the same from your smart contract. I will check for you. Do you remember that we can check the smart contracts that we did in the last class? Like this is the last class. I have you here. Like this is the address of your smart contract name. I copied. I came to Remix, and I will use your address here on the address. I will minimize mine. Here in the address, I will click on the button address, expand the name, and this is your name, Joey, and this is the owner. Check if you are connected with this account, okay? Like if I try to validate your smart contract, I cannot do it because I'm not the owner. Only you can do it. So, is this for today? We try here to to check your name on the master name. And what's the next weeks? What we are doing? Next week, we don't have a live class. For the next 2 weeks, we don't have a live class for Academy, but we will have a different class last week, because some persons are asked me to do an advanced class. It will be part of the Academy for it to be the module 6 or 7, but not now. But if you are confident that you can do an advanced class, you can try it now, no problem. And I will send a link here for you that you can know how to create an NFT, a collectible. This will be our last webinar, next webinar. Oh, I didn't copy it. Wait a minute. So if you go here, you can register for the next webinar. Joey, the owner is this, maybe because you are not connected to the injected Web3. You can check this, okay? Check the environment. Another point, Joe, is that Nifty has an error. And I discovered this last week, because if I pay attention on this, my account begins with 50. If I close my account, I log out, and I log in again, I have a different account here. It's not my account. How to have the right account? I come back to the POA, and then I come back to the RSK. And now this is my account. So we need to check this, okay? And thank you so much, Neil, to be here. And for next week, you will receive an email, because you need to do the exams. I will publish on next week exams for all the modules. So you need to do tests for the wallets, tests for the smart contracts, and tests for the blockchain part. And all the results of your tests will be saved in your profile, okay? So today is this. Joey, you can check your account again. And if you need more help, I can help you on the Slack channel too. And if you would like to try advanced class, try the next webinar. But if you think that it's so advanced, don't worry, because you need more basic classes, more basic smart contract, and then go to the NFT later. It's not a problem too, but it's up to you. So is this, everyone? We finished today, and wait for the next two webinars. I will send the email for you. Probably you are coming back in the beginning of May, first week we are come back. And if you have some doubts, you can review the lessons, you can review the live classes. Thank you, everyone. Joe, Neil, Derek, Abidiel, Ain. See you in the next class. Bye.